Methods of preparing salts. Now, this is all very wordy. These are the kind of things that you really need to do rather than read about and see in pictures. Okay, so in class, hopefully you'll get a chance to make some of these salts and use these methods and understand their real significance. Right, so we're going to kind of slip through this fairly quickly, but you do need to know the outline of the procedure of how to prepare different salts using slightly different methods. Okay? Acid plus something is almost always going to give you a salt, isn't it? You know the four equations that we've looked at already. So the first one we're going to look at is acid plus metal. Now, again, these are practical considerations you must take into account using your experimental techniques that you studied at the beginning of year 10. So what we would do is we would add an excess of the metal to the acid and we would stir until all of the effervescence stops. Why? Because then we know that all of the acid has been used up. We don't want any acid to be left in our salt. We would then filter the excess metal off. Obviously the excess metal stays as the residue, and the filtrate is in the evaporating basin underneath. We can filter directly into an evaporating basin because the next step is that we evaporate off about half the volume of the water until the crystallization point is reached. Now the crystallization point is when we know that if the solution cools, crystals will start to form. And the way to test this is to stick a glass rod into the solution and then take it out and let it cool, and you'll see that solid forms on the surface of the glass rod. So as the solution cools on the glass rod, crystals are formed. You can also see sometimes a ring of solid around the inside of the crystallization dish, the evaporating basin, we call it. Once that's happened, then we can say, right, let's let the solution cool. So we let the evaporating basin cool down, and what will happen is crystals will start to form almost immediately. Now if we want those crystals quickly, we can then filter the mixture again. The crystals stay in the filter paper, and then we can dry the crystals using other filter paper or in an oven at a low temperature, not a high temperature, because it could potentially cause the crystals to thermally decompose. So at a relatively low temperature just to dry them, and then you've got a sample of your crystals, you've got your salt. This method is not suitable if the metal is very reactive, such as potassium or sodium, or if the metal is unreactive, it won't react with an acid, for example, copper or silver. Next one, acid plus insoluble base, typically a metal oxide. So a similar kind of process, we add an excess of the base to warm acid this time because this reaction is quite slow at room temperature. We stir it and we keep adding the base until no more base dissolves. So we'll see the solid floating or sinking, but we'll see the solid present in the solution or in the liquid mixture. Then we filter off the excess base, we collect the filtrate in an evaporating basin, and then we follow the same procedure as before, as you can see. Acid plus carbonate. Carbonates tend to react with acids at room temperature, so we add the excess of the carbonate to the acid and we stir until the effervescence stops. Again, you'll be able to see the carbonate floating around in the mixture. We filter, collect the filtrate, and then the same procedure as before. Remember, we're adding excess carbonate because we want to use up the acid. Now, acid plus alkali is a bit more complicated, simply because you can't actually see the product, and it's very difficult to know when you've added enough of the acid or the alkali. So what we do is we use a titration. So we titrate a small amount of the acid, for example 25 centimeter cubed, with alkali, from a burette, and we use PP. PP is phenolphthalein. Then we get the end point, so we get the point where the acid has just been neutralized by the alkali, and we look at the burette and we know how much of the alkali we added. Let's say we added 27.5 centimeter cubed. Then what we do is we do the same procedure again, but we don't add the alkali this time. So we repeat the titration and we add 25 centimeter cubed of the acid to the conical flask, and then we would add, like I said before, 27.5 centimeter cubed of the alkali, but no indicator. But we know that alkali has just neutralized the acid. So in that mixture now, you've got water and you've got the salt. And then the same procedure is followed. You evaporate off about half the volume until the CP is reached, and then you allow the solution to cool and crystals to form. Okay, and you can filter and dry them if you wanted them straight away. Right, they're the four basic methods of acid plus another substance to produce a salt. Remember, we are preparing salts. Right, let's look at some examples of this. This is up to you to write the equations and to balance them. So acid plus metal, for example, zinc and nitric acid. So you can stop this and write that equation. Okay, there is the equation that you should have written. So if the question said to me, what substances can I use to make zinc nitrate salt, zinc nitrate crystals, then I could say, well, I could use zinc metal and nitric acid. You would have noticed that this still isn't balanced. We need a 2 in front of the nitric acid, don't we? Because we've got 2 nitrates here and we need a 2 there, so that you've got zinc nitrate and 1 water molecule. Okay, you can balance that yourself. Acid plus insoluble base, so metal oxide, for example, iron 3 oxide and hydrochloric acid. Stop me and you can have a try. There you go, the basic formulae. Iron 3 oxide is Fe2O3 because it's an Fe3 plus ion. Reacts with hydrochloric acid to produce a chloride. You get iron 3 chloride and water. And yes, the astute among you will have noticed it still isn't balanced. So let's have a look. What have we got? We've got 2 ions here, so we must have 2 here. If we've got 2 ions, we've also got 2 times 3, 6 chlorides here. So we're going to need 6 chlorides here. And let's check the water out. 6 hydrogens, 2 hydrogens, so that's going to have to be a 3. Double check the oxygens, O3, 3O. Brilliant. Acid plus carbonate, for example, calcium carbonate and sulfuric acid. Have a go. There you go. Does it need balancing? In this case, no. Acid plus alkali, for example, hydrochloric acid and sodium hydroxide. Have a go. Does it need balancing? No. Okay. So there's some examples. You have to be fairly flexible. Sometimes they'll give you the starting materials and you have to say what's produced. Sometimes they'll say what's produced and you have to think of potential starting materials. Right, have a go at those pages. There are lots of questions on the pages too. Have a try.